Today we will discuss on measures of central tendency. After the tabulation and graphical representation of data, we go for data analysis, and there are two measures which we use for data analysis. They are the measures of central tendency and the measures of dispersion. The common measures of central tendency are mean, median and mode, and the measures of dispersion usually used are range, quartile deviation and standard deviation. Mean, median and mode are the three usual measures of central tendency. So we just consider the values of 7 observations. So we are making a study in which we get 7 observations which are not grouped. So these observations are 25, 36, 22, 34, 31, 33 and 22. We can calculate the mean, median and mode for all these observations. So we are measuring the central tendency of these observations. So how do we calculate mean? There are 7 observations. So to calculate mean, we will add or we will take the sum of all the observations and divide it by 7. That gives the value 29. So 29 is the mean value of all these observations. So it can be considered to be the central value. Then what is median? For finding out median, we have to first arrange all these observations in either ascending order or descending order. So here you can see that I have arranged them in the ascending order, starting from 22, then 22 is repeated, 25, 31, 33, 34, 36. Since there are 7 observations, the 4th observation in either ascending or descending order will be the median. So that is the middle value. It is the middle value of all the observations. So here the median is 31. Now we come to mode. Mode is the most frequently observed value. So here you can see that in these observations 22 is repeated twice, but all the other observations appear only once. So 22 is the most frequently observed observation, and that is the mode. So we will define arithmetic mean, median and mode based on the answers. Arithmetic mean is the sum of all the results included in the sample divided by the number of observations. Median is the middle value of all the results arranged in ascending order or descending order, whereas mode is the most frequently observed value of the measurements in the sample. We will go to another data which is again an ungrouped data, where we have taken the length of a juvenile fish obtained from a pond. So there are 10 fish we have obtained, and we have measured their length in millimeters, which we get as 67, 69, 66, 68, 72, 63, 76, 65, 70 and 74. Here mean will be the sum of all these observations divided by the total number of observations, and the sum is 690 divided by 10 is equal to 69. Median will be the middle value. So first we have to arrange them in ascending order. There are 10 observations. So since there are 10, the median will be there will be no middle value. There will be 2 middle values, that is 68 and 69. So what we do is you take both the values and calculate their mean. So that is median. So here when we arrange the 10 values in ascending order, 68 and 69 come in the middle. So we take their mean, and that will be the median. We will calculate mode now. Look at all these observations. There is no observation which is repeated. All the observations or each observation is appearing only once. So all the values are having equal frequency, that is 1. Hence here there is no way to calculate the mode. So it will be the same as mean. Next we go to a group data. where we can see the frequency of each observation as a discrete series. So here imagine we have conducted the study of tiger distribution in different sanctuaries of India. So here is the frequency table, where you can see that there are 20 sanctuaries with a tiger population of 8, 25 sanctuaries with a tiger population of 6, 18 sanctuaries with 10, 25 sanctuaries with a tiger population of 4 and 11 sanctuaries with a tiger population of 7. So here 8, 6, 10, 4 and 7 are the observations. 20, 25, 18, 25 and 11 are the frequencies. So we rewrite it as observation and frequency here. So here to find out mean, we have to first multiply the observation with the frequency. So that is xi into fi, where xi is the observation, value of the observation, and fi is the frequency. So we have to multiply each observation with its corresponding frequency. Here you can see 8 into 20, 160, 6 into 25, 150, 10 into 18, 180, 4 into 25, 100, 7 into 11 is equal to 77. Now we have to add, or we have to find out the sum of all these multiplied values. That means we have to find the sum of xi, all xi fi, and we get the value as 667. Now, so total, how many observations are there? The total number of observations will be equal to the sum of the frequencies. So that is equal to 99. Because the study was conducted in 99 sanctuaries, of which 20 had a tiger population of 8, 25 had a tiger population of 6, 25 had a tiger population of 10, 18 had a tiger population of 10 and 11 with a tiger population of 7. So the total number of observations was 99, because 99 sanctuaries were under study. So how do we calculate mean for such an observation? So we will divide the sum of xi fi by the total number of observations, that is n. So the value will be 667 by 99, that is equal to 6.73 per sanctuary will be the mean. For the same data, we will find out how we calculate median. Mean was the average, but median is the middle observation. So what we first do is, we will arrange the observations in either the ascending or the descending order. So here I have arranged in the descending order. All the observations have been arranged in the descending order, that is 10, 8, 7, 6 and 4. And then in the next column I write the frequencies. And now in the third column I find out the cumulative frequencies. How we calculate cumulative frequency? That is, here the frequency is 18. So we write the corresponding cumulative frequency as 18 itself. Next cell, what we do is, we will add up the second frequency to the first. That is what is called as cumulative frequency. So 18 plus 20 is equal to 38. Now we move on to the next cell, where we add this frequency to the next one. So we are getting 38 plus 11, that is equal to 49. When we move on to the next cell, the cumulative frequency will be 49 plus 25 is equal to 74. And moving on to the next one, we will be getting 74 plus 25 is equal to 99. And there are total 99 observations. So this is the cumulative frequency. So here, unlike mean, there is no need of multiplying the observation value with the value of the frequency. We are just arranging the observations in the ascending or the descending order, and we are only finding out the cumulative frequency. So there are 99 observations. Since 99 is an odd number, the middle value will be 99 plus 1 by 2th observation, that is 100 by 2th observation, that is 50th observation will be lying in the middle, with 49 observations on the left side and 49 observations on the right side. So the median will be n plus 1 by 2th observation. So the 50th observation is the median. And how can we calculate the 50th observation? So for that we go to the cumulative frequency table. Here, where will 59 come? So here the number is 49. The 50th observation comes in this cumulative frequency cell. That is here it starts from 50 to 74. So all frequencies from 1 to 18 lie here, and all observations from 19 to 38 lie here. All observations from 39 to 49 lie here. All observations from 50 to 74 lie here. All observations from 75 to 99 lie here. So we have to find the 50th observation, and the 50th observation lies in this cumulative frequency. And therefore, the observation value that corresponds to it is 6. So all the observations from 50 to 74, since it comes under the observation value 6, the median will be 6, because that will be the middle value if all of them are arranged either in ascending order or descending order. But since there are 99 observations, instead of arranging them in ascending or descending order, we are finding out the cumulative frequency. By finding out the cumulative frequency, we will be easily able to find out which is the middle value by applying these formulae. Now we will calculate the mode for group data, which is again tabulated as a discrete series of or a frequency table. So here are the observations and here are the frequencies. So I have just increased the number of observations. Suppose we are studying again the tiger population. So these are the various values we get: 4, 5, 6, 8, 10, 7, etc. And these are the frequencies. These show the number of sanctuaries showing the corresponding values of tiger population. But to find mode, we have to follow 2 steps. First, we have to prepare a grouping table, which is followed by preparation of an analysis table. So first, what is a grouping table? A grouping table will have 6 columns. The first column will be having the original frequencies. The second column, in the second column, we will combine the frequencies of column 1 2 by 2. That means 20 plus 25, 18 plus 14, 11 plus 10, 23 plus 22, 24 plus 18, like that. So that is how we write values in column 2. Now column 3. In column 3, the frequencies of column 1 are combined 2 by 2, but we leave the first one. That is, we leave the first one. That is 25 plus 18, 14 plus 11, 10 plus 23, like that. Now in column 4, we will combine the frequencies of column 1 in 3 by 3 as 3 by 3. That is the 3 observations, then followed by 3 observations. In column 5, the frequencies of column 1 are combined again 3 by 3, leaving the first one. In column 6, frequencies of column 1 are combined 3 by 3, leaving the first 2. So in all these columns, the maximum frequency obtained is to be marked as bold. So we will go to how we do it. This is not in the increasing or decreasing order. So before preparing a grouping table, we have to arrange the values of observations in either the ascending or the descending order. So these are the observations as earlier shown, but I have arranged the values of the observations in the ascending order, because earlier we had it kind of dismantled like 8, 6, 10, 4, 7, not in an order. But here you can see all the values of the observations have been arranged in the ascending order, starting from 4 and ending in 13. Now, the frequency corresponding to 4 was 14, as you can see from this table. The frequency corresponding to 5 is 10, as we can see from this table. The frequency corresponding to 6 was 25, as you can see from this table. So, the entire table has been rearranged in such a way that the values of the observations are written either in ascending or descending order. So, this is column 1, where we write all the frequencies corresponding to the observations. So, column 1 is over. Altogether, we need 6 columns. So, what is column 2? In column 2, we combine the frequencies of column 1 as 2 by 2. How? So, here, the first two are 14 and 10. So, they are combined and written in column 2 as 24. The next two are 25 and 11. So, they are combined and written as 36. The next will be 20 and 24 combined and written as 44. 18 and 22 gives 40. 23 plus 18 gives 41. So, this is how column 2 is prepared. That is, the frequencies of column 1 are combined 2 by 2. Now, what will be column 3? The frequencies of column 1 are combined 2 by 2, leaving the first one. So, we will see how we do that. Look. So, here this is column 3. We leave the first one, that is 14 is left out, and we combine the others 2 by 2. 10 plus 25 gives 35. 11 plus 20 gives 31. 24 plus 18 gives 42. 22 plus 23 gives 45, and we are leaving out the last one. So, that is column 3. Now, we go to column 4. Column 4 represents frequencies of column 1 combined 3 by 3. So, we go to column 4. The first three, 14, 10 and 25 are combined, you get 49. 11, 20 and 24 combined, you are getting 55. 18, 22 and 23 combined, you are getting 63, and the last one is left out. So, that is column 4. Now, column 5. In column 5, we combine the frequencies 3 by 3, leaving the first one. So, 14 is left out. Then 10 plus 25 plus 11, that is equal to 46. 20 plus 24 plus 18 is equal to 62. 22 plus 23 plus 18 is equal to 63. Now, the last column, that is column 6. In column 6, the frequencies of column 1 are combined 3 by 3, leaving the first two. So, here you can see the first two, 14 and 10 are left out, and we combine 25 plus 11 plus 20 is equal to 56. Then 24 plus 18 plus 22 is equal to, 24 plus 18 plus 22 is equal to 64, and we leave out 23 and 18. So, this is how we make the 6 columns. The first column, it represents the original frequencies. The second column represents the frequencies combined 2 by 2. The third column represents the frequencies combined 2 by 2, leaving the first one. Fourth column represents the frequencies combined 3 by 3. Fifth column represents the frequencies combined 3 by 3, leaving the first one. And sixth column represents the frequencies combined 3 by 3, leaving the first two. Now, in all these columns, we have to mark the highest frequency. So, here in this column, 25 is the highest. In the second column, 44 is the highest. In the third column, 45 is the highest. In the fourth one, 63 is the highest. In the fifth column, 63 again is highest, and in the sixth column, 64 is highest. So, preparation of grouping table is over. Now, preparation of analysis table. So, it is from this grouping table that we are going to prepare the analysis table. So, here I have rewritten, or I have taken the same table, say so I have cut and pasted the same table, same grouping table here. Now, I prepare an analysis table. In the analysis table, on the right hand side, I'll write the probable values of mode. That means the values of all the observations. They are 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. So that is being written on the right side. So any of these has a chance to be mode, the mode value. So all these are written on the right hand side. On the left hand side, I'll write the column numbers. There are 6 columns. Now what I do? You take the first column. In the first column, which is the highest frequency? It was 25. And 25, it corresponds to 6, to the observation 6. So I put a tally bar under 6. So that is regarding column 1. So in column 1, the highest frequency was 25, which corresponded to 6. So I put a tally bar under 6. Now moving to the second column. In the second column, 44 was the highest observation, and 44 is the sum of 20 plus 24, which corresponded to 8 and 9. So I put tally bars under 8 and 9. So in column 2, 44 being the highest observation and it being the sum of 20 and 24, which corresponded to the observations 8 and 9, I put tally bars under 8 and 9. Now I go to column 3. In column 3, 45 is the highest observation and 45 is the sum of 22 and 23, which corresponded to the observations 11 and 12. So I put tally bars under 11 and 12. Then in column 4, 63 is the highest observation, which corresponded to 10, 11 and 12, or it is the sum of 18, 22 and 23, which are the frequencies of 10, 11 and 12. So I put tally bars under 10, 11 and 12. Then the fifth column. 63 is the highest observation in the fifth column. You can see 46, 62 and 63 are there, of which 63 is the highest. And 63 is the sum of 22, 23 and 18, which correspond to 11, 12 and 13. So I put tally bars under 11, 12 and 13. And the last one is column 6, whose highest value is 64, which is the sum of 24, 18 and 22, which are the frequencies of 9, 10 and 11. So I put tally bars under 9, 10 and 11. And these are the observations which we have written on the right hand side. Any one of these can be the mode value. So what is mode value? The mostly repeated value, the one which has the maximum frequency. So we are just counting the tally bars under each one. 4, there are no tally bars. 5, there are no tally bars. Under 6, there is 1. So we write the frequency as 1. Under 7, there is none. So it is 0. Under 8, you have 1. Under 9, you have 1 and 2. Under 10, you have 1, 2. Under 11, you have 1, 2, 3, 4. Under 12, you have 1, 2, 3. Under 13, you have 1. So, each one, the frequency of each observation in this table, in the grouping table, is written here. So, here 4 is the highest value, which is the frequency of 11. That means it is under 11 that we get the maximum frequency. So, 11 will be the mode. So, that is how mode is being calculated. The observation 11 occurs maximum number of times, that is 4 times, hence the mode is 11. Now we will see the merits and demerits of the measures of central tendency. So we first go to the merits of mean. Mean is easy to compute and it is a rigidly defined formula. That is, if the same problem is done by different experimenters or different persons, they will be getting the same value for mean. So it's a rigidly defined formula giving the same results for every computing person for a single problem. It takes into account all the observations because we are taking the sum of all the observations and dividing it by the number of observations. And it is that value which is least affected by sampling fluctuations because we are studying a population and one person is taking a sample from population, another person is taking another sample from the population, and there will be sampling fluctuations. But out of all the measures of central tendency, mean is that one which is least affected by sampling fluctuations, but median and mode will be different according to the sampling fluctuations, but mean has a lesser tendency to be different. Then it balances the values on either side, and it is the best measure to compare two or more series, and it is calculated on value, not on position. But we can see that median is based on position. It is the positional average. So these are the merits of mean. But there are some demerits, that is, it cannot be calculated if all the values are not known. So all values are to be known, and the extreme values will have greater effects on mean. They will affect mean. The difference in extreme values, if there will be very high difference in the highest and lowest number or observations, mean will be affected. And it cannot be determined for qualitative data like beauty, work proficiency, etc. Now we will go to the merits and demerits of median. Median is an easily understood value because it is the middlemost of all the observations. It is not influenced by the variation in the magnitude of the extreme items. Whatever be the extreme values, it doesn't affect mean, it will be the central value. And the value can be graphically ascertained with the help of frequency curves or ogives, and it is the best measure for qualitative data. That means you can say, you can rate certain aspects like beauty as 1, 2, 3, 4, 5, etc. So like excellent, very good, good, bad, very bad, like that. So it is the best measure for qualitative data, and it can be determined even by inspection. But mean cannot be used for measuring qualitative data. For that we can make use of median. But the demerits are, for calculating median, the data needs to be arranged for calculation. It has to be arranged either in the ascending or the descending order, and median is a positional average. So it doesn't take into account all the observations, whereas mean takes into account all the observations. It is not subjected to algebraic treatment, that is, we are not applying a formula to find out median, we are just taking the middle observation, and it is affected by sampling fluctuations than arithmetic mean. Mean is the least affected by sampling fluctuations. Then the merits of mode. Mode is the most repeated value. It can be obtained again by inspection. It is not affected by extreme values, just like median. Whatever be the extremes, median will be the middle value and mode will be the most repeated value. So extreme values doesn't have any effect on mean or on median or mode, but it is affecting mean value. It is easily understood. It can be used to describe qualitative phenomenon, and the value of mode can also be found graphically. The demerits are, mode has no significance unless a large number of observations is available. Then it cannot be treated algebraically. It doesn't rigidly define measure because it can vary according to the experimenter, and the data need to be arranged in the form of a frequency distribution. Then only we will be able to calculate mode.